It's 2021, the age of innovation. So why is traveling from planet to planet in just a few days or hours still impossible? It takes us years to send an unmanned probe to another planet in our own solar system. Seriously, why can't we just travel at the speed of light already? Right now, the fastest way to travel in space doesn't even include the use of rockets, and it's something that comets have been doing since the first star was born. I introduce to you the gravity slingshot, or gravity assist. No, not that kind of slingshot. So what is a gravity slingshot? Well, here's the thing. It's not even a machine. It's more of a maneuver that already exists in space and we just take advantage of. So we use gravity assist because it can speed up any spacecraft without using much or even any fuel. But for gravity assist to work, you have to get like scary close to a planet, and you have to be going really fast so you don't get sucked in by the planet's gravity and crash. Okay, but how does it work? Well, back on Earth, you can sort of picture how the slingshot works by throwing a ball at a moving car. Notice how the ball is thrown at a velocity similar to a spacecraft, and the car is also moving similar to a planet, and they're moving in opposite directions. But when the ball hits the car, it bounces upwards and to the left of the screen. It is also moving much faster, which is seen as the ball goes much higher and further than it would have if it didn't hit the car. The ball goes upwards due to the angle of the windshield, otherwise the ball would just go in the opposite direction. The velocity of the ball increases because the car adds its velocity to the balls, making the resultant or actual velocity much greater than it was originally. Now, say that a planet is moving at a velocity going this way around the sun and as fast as this arrow. And the spacecraft is coming from here and has a velocity the size of this arrow. And because the planet is moving this way and is attracting the spacecraft with its gravitational field, the resultant velocity is going to look like this, showing how the spacecraft is actually speeding up as it goes towards the planet. But when the spacecraft leaves the planet, it's now moving in the same direction as the planet, like the ball after hitting the car. And boom, the resultant velocity looks like this. It's like the planet gives the spacecraft a big hug, pulls it in, swings it around, and pushes it out really fast. And when you compare the initial and end velocities, you can see the end velocity is actually much bigger. Meaning, when the spacecraft left the planet, it was going a lot faster than it was before, and the spacecraft can do this with many planets to get even more speed. And the closer you are to the planet and the bigger the planet is, the faster the spacecraft can get because the planet will pull it in for a closer hug and push it out even faster. The thing is, this extra speed the spacecraft gets doesn't just come from nowhere. The spacecraft actually steals it from the planet, like a thief. So the planet will orbit the sun slower, but this change is so small we just treat it like it isn't there. The car was also slowed by the tennis ball, but it's such a small loss you also can't see a change. This maneuver has been used to reach destinations we would have otherwise been unable to reach, like Voyager 1, which used the gravity assist of Jupiter to go beyond our solar system, where it currently explores our universe. And if we could find a way to use gravity slingshots with stars and not just planets, imagine what kind of speeds we could reach and where humans could go.